So it looks like the last thing we spoke about was multiplying fractions. And we learned that to multiply fractions, you want to simplify first, and then what's left over you can multiply. So the very first example that we looked at, and what I'll do is I'll just erase this and just redo it. Here we go. So the very first example here is 3 over 7 times 5 over 11. Now, you should already have this in your notes, so don't worry about writing it down. Just watch, okay? If you wanted to, you could legit multiply from left. Oh, bless you.
Thanks.
You're welcome. If you wanted to, you can multiply from left to right. That's fine. 3 times 5, 15. 7 times 11, 77. But here's the problem. You always need to reduce all of your fractions. You have to. So now the problem would be, okay, well, if you have to reduce this, the easiest way for us to do that is to prime factorize each of the numbers. So the prime factorization of 15 is 3 times 5. And the prime factorization of 77 is 7 times 11. Okay? Are there any questions there so far? All right. Now, if you look in the numerator and denominator, you're trying to find numbers that are the same on the top and bottom, because if they are, you're going to apply this property that I'm writing in the upper right-hand corner of your screen, which is n over n equals 1. Well, that doesn't occur with our problem right here. Remember, prime factorization of 15 is 3 times 5. Prime factorization of 77 is 7 times 11. Since there are no numbers that are the same in the numerator and denominator, you know that is completely reduced. Okay? Now, we're going to skip B. We're going to go to C, okay? Because I want to go ahead and do this again. Now, if you want to, just wait a minute before you write this down, because I want to show you what's happening, okay? All I want to do is show you, all right? So, first things first, okay? If we wanted to, we could go ahead and we can multiply this left to right. So 6 times 7 is 42. And 77 times 8 is 616. Now, here's the issue with this. You still have to reduce. Okay? It's going to take you a long time to do this. Because what you have to do is you have to prime factorize 42, and then you have to prime factorize 616. And that takes some time. So, if you want to go through this way, that's fine with me. You still have to reduce. Here's what I'm saying to do. We are going to simplify first. And what I mean by that is this. Now, all I want you to do is watch. I want you to see what I'm writing here, okay? This number 6, I'm going to rewrite it as 2 times 3. The 77 in the denominator, I'm going to write as 7 times 11. Okay? Now, I put a multiplication symbol, and I'm going to do the second fraction. 7 is already prime, so I leave it. And then the 8, I'm going to write as 2 times 4. Okay? Are there any questions with what I have so far? Are there any questions so far? All right, now, like I said, just watch the screen. Here's what I know. I know that if I wanted to, I can multiply from left to right. So what I'm going to do is I'm just going to rewrite this from left to right. So I'm going to put just one big numerator, 2 times 3 times 7. And I'm going to do the same thing with the denominator, except I'm going to put it in order. So I'm going to write 2 times 4 times 7 times 11. Okay? Are there any questions there? All right. Now, here's the key. I'm going to apply, and I'm going to write the rule in red underneath here, n over n equals 1. In other words, I'm looking for numbers that are the same in the numerator and denominator. And all I'm going to do is just kind of, I'm going to cross them out because I know that's going to eventually turn out to a 1. So watch, like I said, please just watch. 2 over 2. I can cross these out. I know they turn into a 1. 7 over 7. I can cross them out. I know that turns into a 1. So now that I'm done doing that, there's no other numbers that are the same on the top and bottom. I'm going to write what is ever left over. And last, I'm going to multiply. The numerator 3, nothing can change there. I'm not multiplying that by anything. And 4 times 11 is 44. And the best part, I know that's reduced because I already reduced it in this step right here. So 6 over 7 times 7 over 8 equals 3 over 44. Does that make sense, everyone? Does everybody see what I just did there?
Yeah.
Okay, good. Oh, now we can go back to part B. Okay, now we can go back to part B. So I'm going to do the same thing that I did previously. I'm going to write out one big numerator and one big denominator. So I got 2x in the numerator and 3 times 9x in the denominator. Once again, I'm looking for numbers or things that are the same in the top and the bottom. In other words, numbers or variables that are the same in the numerator and denominator. Hopefully, everyone can see that you have an x in the numerator and an x in the denominator. I know that will reduce down to a 1. Okay? Once I reduce, I write what's ever left over. So the 2 stays the same. There's nothing to multiply there. And then the 3 times 9. Well, 3 times 9 is 27. And I know that's already reduced, and it's because I already did it. Does that make sense, everyone? So the key to multiplying fractions, and to be honest with you, dividing fractions, the key is to simplify first, and then do the operation. Okay? Simplify first, then do the operation. All right, let's look at letter D. 6 over 7 times 14 over 27. Now, if you're following along, you should hopefully see that the first thing I'm going to do is I'm going to rewrite the 6 as 2 times 3. The denominator 7. 7 is prime, so I leave it like that. Now, let's work on the second fraction. The second fraction is 14. So, that's 2 times 7. And then the 27, I know that's going to be 3 times 9. Okay? Now I'm going to rewrite in order. And I do that so it's easier for me to see things. So I get 2 times 2 times 3 times 7 all over 3 times 7 times 9. Okay? Now, go ahead.
So how you wrote at the bottom 3 times 7 times 9, does it have to be in that order, or it can't be 7 times 3 times 9 the way you wrote
it? It could be any order you want it to be. I put them in numerical order because it's easier for me to see. Okay? So all I'm going to do here is just rewrite it. So all I'm doing is rewriting. All right. Now I'm going to look for numbers that are the same in the numerator and denominator. That occurs here. 3 over 3 and 7 over 7. All right. So there is my reduce. I just reduced everything right here. Now it's completely reduced. What's ever left over is what I'm going to write. 2 times 2 over 9, which equals 4 over 9. So 6 over 7 times 14 over 27 equals 4 over 9. Okay? Are there any questions? Yes or no? All right. We're looking good. So you have the tools to do this. Section, what is it, 4.2? Let me go back. Yeah. Section 4.2, factors in simplest form is the key to all this. That's why it's so important that you know how to write the prime factorization of a number, and then you know how to simplify. Because everything else is just easy. It's just multiplying. That's it. We'll do 2 more examples here. Okay? So 4 over 27 times negative 3 over 8. This one, simple. First things first. Let's get the easy part out of the way. We'll get the easy part out of the way. We have a positive number times a negative number. Can somebody tell me what a positive times a negative is?
Negative.
Perfect. So our answer is going to be negative. Okay? Like, I know that. Now let's go ahead. Let's simplify first. Then we multiply what's ever left over. So the 4. I'm going to write that as 2 times 2. The 27. I'll write as 3 times 9. Now I have my second fraction, and it's negative. So I put a negative sign. 3 is prime. There's nothing I can do there. And 8 is really 2 times 2 times 2.
Why didn't you do 9 as 3 times 3 then?
Because I don't have to. You'll see why, Mike. You'll see why. Are there any questions so far? All right, let's put it in order. Go ahead.
So would it be wrong to write 4 times 2?
No, that's correct as well.
Okay.
All right.
Why you did it now?
All right. So, Mike, if you could see it, that's good. So let's put it in order. I know the answer is going to be negative. So I put a negative symbol out front. I'm going to write the numerator in order. 2 times 2 times 3. And then my denominator. All right, 2 times 2 times 2 times 3 times 9. So all I'm doing is just writing it in order. All right, here comes the fun part. We get to reduce. So if you're looking at the screen, I can reduce 2 over 2. I can do another 2 over 2. I can do a 3 over 3. Now, since everything in the numerator reduced, what does it turn into? Remember, when you reduce, it turns into 1 over 1, 1 over 1, and 1 over 1. So if everything is reduced in the numerator or denominator, but in this case it's the numerator, it turns into a 1. Because 1 times 1 times 1 is 1. Now, look at your denominator. 2 times 9. And what is 2 times 9? 18. So, Mike, you see why I didn't have to write it like that?
Yeah, it was easier just to reduce it like that.
Mm-hmm.
Right after I said it, I looked and I was like, oh, 2 up top, and then you can make 2 on the bottom, so they just reduce themselves.
Yep. And Kaylee, same thing with you. If you wanted to make that 8 just 2 times 4, that's fine. And then you can reduce the 4s. Okay? Doesn't matter. All right. Last problem. A to the third over b to the second times b over a to the second. I love this problem. It's the easiest one that we're going to be doing. This is by far the easiest because there's no numbers. All you have to do is just write out what they mean. A to the third. That means a times a times a. All over b to the second. B times b. Now for the second fraction. You have a b in the numerator. And then a to the second is just a times a. If you wanted to, you can rewrite this so it's in alphabetical order. So your numerator is going to stay the same. But your denominator, you just switch them. So it's a times a and b times b. And then from here, numbers are the same in the top and bottom. So the a's reduce and one of the b's reduce. You rewrite what's ever left over. A over b. Are there any questions? All right, good. Scroll up just a little bit. Now, that last example leads us directly into the next example, which is simplifying fractions that contain exponents. Because it all goes back to, do you know what an exponent means? So in the previous example, letter F, when we had a to the third power, that meant a times a times a. Well, if I have in letter G 3 over 4 to the third power, well, that means 3 over 4 times 3 over 4 times 3 over 4. Now, do we see any numbers that are the same in the numerator and denominator? Yes or no? Do you see any numbers that are the same in both numerator and denominator?
No.
No. So I know this is already reduced. I just need to figure out what is it equal. 3 times 3 is 9. 9 times 3 is 27. 4 times 4 is 16. And 16 times 4 is 64. And I know this cannot be reduced because if it could, I would have done it at the very start. How are we looking so far? Pretty good? All right. Oh, sorry. Moving too fast, I think. Let me take a drink. All right. So when we divide fractions, the first thing we need to learn is this thing called a reciprocal. All right, which is this fancy word at the very end. So our book gives us this nice definition. I'm going to kind of sum it up real quick. The reciprocal is nothing more than taking a fraction and flipping it. It's like taking a fraction and making it to a headstand. That's it. That's what a reciprocal is. Now, the reason why we like reciprocals is because they allow us to divide fractions. All right? So let me show you a picture here. We're going to come all the way down. We're just going to do this example right here. All right? I'm just going to show you how to do it. So I have 8 over 9 divided by 2 over 9. Okay? Now, technically, this is what it looks like. And please just watch. You don't have to write this down. Just watch. Eight over 9 divided by 2 over 9 is really this massive fraction that I have. This in the numerator, it's 8 over 9. And then in the denominator, it's 2 over 9. But here's the thing. We hate fractions in the, and I'm going to use quotation marks. We hate fractions in the bottom. Like, I don't want to have a fraction and then divide by another fraction. Like that to me, I don't like it. So here's what I'm going to do. I'm going to be really clever on how I do this. So like I said, all you got to do is just watch. Oh boy. There we go. Excuse me. I am going to multiply both of these fractions, 8 over 9 and 2 over 9, by something very special. Now, here's the thing. I don't like fractions in the bottom. The only number that I really want in the bottom is a number 1. In other words, we want a number 1 in the bottom. The only way I can get a number 1 in the bottom is by multiplying by the reciprocal. Because if you think about it, here's what happens. Watch. I have 2 over 9. If I wrote the reciprocal, that's going to be 9 over 2. And whatever I do to the bottom, I'm going to do to the top as well, okay? But regardless, I want us to focus right down here. Because notice, I have a 2 in the top and a 2 in the bottom, a 9 on the top and a 9 on the bottom. So what's really happening here is the 2's reduce, they turn into a 1, and the 9's reduce, and they turn into a 1. So I get that number 1 in the denominator that I really wanted. In the numerator, all I have to take is 8 over 9 and multiply by 9 over 2. The 9's reduce, so I'm left over with 8 over 2. Now, since that 8 over 2, since that whole thing is over 1, I don't even have to write the over 1 anymore. In other words, I took 2 ugly fractions and just made it into one nice one. The only thing I have to do here is just say, okay, well, what's 8 divided by 2? The answer to that is 4. So here's what you were taught a long time ago. And please correct me if I'm wrong. All right? So I'm going to erase all this, and we're going to do this problem again. But we're going to do it the way that you were taught. So if you've ever seen this before, you were taught this. To divide fractions, you rewrite the first. The division symbol will change to multiplication. And you write the reciprocal of the second. How many of us remember that? Keep, flip, change, KFC. But you were never taught why. You were just told, just do this. Now I'm showing you why. Okay? The why all comes from the fact that we hate fractions downstairs. So what we really did is we multiplied both of them by the reciprocal of the bottom fraction, that second fraction, because it created that number 1 that we wanted. So from now on, hopefully you understand why we're doing this, and hopefully you see, wow, dividing fractions is nothing more than just multiplying by the reciprocal. In other words, it's another multiplication problem. The only thing you got to do is flip it first. Does that make sense, everyone? Yes or no? Okay. So, let's go ahead and do the second one now. We'll do letter I. 4 over 9 divided by 1/2. Step 1, rewrite 4 over 9. Step 2, change division into multiplication. And then step 3, you're going to write the reciprocal of 1/2. The reciprocal of 1/2 is 2 over 1. Okay? From here, if you can simplify, go for it. I'm going to tell you we can't. How do I know that? Well, you got a 9 in the denominator, and in the numerator, You have a 4 and a 2. They will not go into 9 at all. So you know it's already simplified. All you have to do is multiply now. 4 times 2 is 8. 9 times 1 is 9. So the answer is 8 over 9. Does that make sense, everyone? Okay. All right, next problem. Letter J looks crazy, but it's not. It's very simple. First, you read it. 3 times y divided by 4. Divided by 5y over 3. Or I'm sorry, 5y to the third power. I missaid that. So because you have this division symbol, let's rewrite it first. So you rewrite the first fraction. Division changes the multiplication. Now we need the reciprocal of 5y to the third.
Wouldn't it be 1 over 5y to the third?
Yes. So what I'm going to write is this. Note, you can make any number a fraction by putting a 1 underneath it. You can make any number you want a fraction just by putting a division symbol, or better yet, the fraction bar, I think is the better way to say it. So you can make any number a fraction by putting the fraction bar and a 1 underneath it. So if I need to multiply by the reciprocal of 5y to the third over 1, well, the reciprocal of 5y to the third over 1 is 1 over 5y to the third. Did it again. So from here, let's just go ahead. Let's try to simplify if we can. Oops. So in the numerator, I get 3y. In my denominator, excuse me, I'm going to get 4 times 5. And then I'm going to write 3 y's. Because y to the third means y times y times y. Okay? Do we see anything that is the same in the numerator and denominator? Yes or no? And then obviously I'm going to say, what is it?
The y.
I love it. So I can scratch out one of them on the top and one on the bottom. Now, I know if I really wanted to break this all the way down, I can rewrite 4 because 4 is composite. It's not prime. It's composite. I can rewrite 4 as 2 times 2. Does anything else simplify? Yes or no? I agree with Leah. No. So, your numerator is a 3. Your denominator, you're going to have to multiply. 2 times 2 is 4. 4 times 5 is 20. And you have 2 y's. So write y to the second. Does that make sense, everyone? Good, good. For letter K, you got to do the work inside the parentheses. This is one of our order of operations. This is one of our order of operations here, okay? So you got to do the work inside the parentheses. My suggestion to you, draw a line and just do little things at a time. You don't got to go crazy with this. Nobody says you have to do the entire problem all at once. Okay? Now my cat wants me to hold him. So I'm going to hold him for a couple minutes. All right? So here we go. Negative 2 over 3 times 9 over 14. That's what I'm going to do first because it's inside the parentheses. So off to the right. I'm just going to do this. So let's try to simplify first. So I know 9 is really 3 times 3. I know 14 is 2 times 7. I look for numbers that are the same in the top and bottom. So that's going to be a 2 and a 3. So it looks like negative 2/3 times 9 over 14 is negative 3 over 7. Does that make sense so far, everybody? Okay. So now that I did the work inside the parentheses, I'm going to go ahead and divide. I rewrite the first. I multiply by the reciprocal of the second. So I look for numbers that are the same in the top and the bottom. Now that 15, you got to remember 15 is really 3 times 5. But if you notice, the 3's are on the same side. Let me go ahead and rewrite that so you can actually see it. I'm trying to give myself a little bit more space here. See, the 3's, although you see them, they're both in the numerator. There's nothing you can do there. So you legit have to multiply all this out. So, negative 3 times 15, negative 45. And 7 times 7 is 49. And there's your final answer. Okay? Oops, sorry. I hit that by accident. Are there any questions? All right. Last objective is actually really simple. All you got to do is just multiply or divide by giving the fractional replacement values. So here's an example. If x equals negative 3 over 4 and y equals 9 over 2, evaluate x times y, and then do x divided by y. So it's a lot easier than you think. All right, x times y is just negative 3/4 times 9 over 2. Remember, you try to reduce if you can. Notice nothing reduces. All my 3's happen to be in a numerator. All my 2's happen to be in a denominator when I prime factorize. There's nothing I can do here. So the answer is negative 27 over 8 when you multiply. Nothing you can do there. Now, for the second example, we set it up almost the same way. Instead of multiplying, we're dividing. But from here, notice things change now. You rewrite the first fraction. You multiply by the reciprocal of the second fraction. Now we're going to rewrite it. So we prime factorize to see if anything reduces. So the 4 is 2 times 2. The 9 is 3 times 3. And then from here, we can definitely see, okay, I'm going to reduce some stuff. I got 1, 3 in the numerator. And 1, 2 in the numerator also. All my numerators reduced. I know that's a 1. And 2 times 3 is 6. So the answer is negative 1/6. Okay, are there any questions? Am I moving too fast? Are we okay? All right. Section 4. Easiest section in the book. Easiest one. So here's what we're looking at. I like this picture. I think it really drives home what we're doing. So in section 4 and section 5, we're talking about adding or subtracting fractions. Okay? That's what we're talking about, adding or subtracting fractions. Now, within section 4, we're doing like fractions. And what we mean by like fractions, the denominators are the same. Okay? So like a really cool little picture here is 1/5 plus 3/5. Notice the pictures are the exact same. You have 5 total blocks, and each one is shaded appropriately. In the first, you got 1 shaded, and the second, you have 3 shaded. Because these blocks look the exact same, we are allowed to add. So the only thing we add are going to be the numerators. 1 plus 4 or 1 plus 3 equals 4. So if you think about it, if you brought these blocks together and these blocks together, you would have a total of 1, 2, 3, 4 shaded blocks. So in section 4, all you're looking for is, do they have the same denominator? If they do, you're going to add the numerators, which is exactly what this big rule right here says. If you are adding or subtracting with like fractions, meaning the same exact denominator, all you're going to do is rewrite the denominator and then add or subtract the numerators. So if we look at letter A, notice they both have a 13 for a denominator. So the easiest way to do this is just to rewrite it. So you have 6 plus 2 in the numerator. And we know 6 plus 2 is 8. The last thing is, and I'm gonna highlight it in the directions, you always want to make sure that you're simplified. Since 13 is prime, I know that's it. 13 does not reduce at 8. So 8 over 13, call it a day. All right. For letter B, 5 over 8x plus 1 over 8x. It doesn't matter about the x. I don't care about that. What I care about are the denominators the exact same. In this case, they are. So I write 5 plus 1 and an entire thing over 8x. I know 5 plus 1 is 6 over 8x. And like I said, you always want to make sure your answer is reduced. 6 is 2 times 3. 8 is 2 times 4 times x. I can see that the 2's reduce. To give me 3 over 4x. Okay? Any questions so far? All right. The only thing I'm going to do here is I'm not going to go super fast, but I'm just going to speed up just a little bit. Because the lesson for this is you're looking for the common denominator. Next one. We got 11. That's the same. All I have to worry about is adding up the numerators. So let's see here. 20 plus 6 is 26 plus 7 is 33 over 11. Now I reduce. I know 33 is 3 times 11. Therefore, the 11s reduce. Since everything in my denominator reduced, that's a 1. So the answer is just 3. So 20 over 11 plus 6 over 11 plus 7 over 11 equals 3. Okay? Next one, 11 over 12 minus 6 over 12. Denominators are the same, so rewrite it. And write the numerator, 11 minus 6. 11 minus 6 is 5. I know that's completely reduced. Oh, sorry. Is this making a lot of sense? Is this pretty easy? All right. We'll do one more here. Once again, denominators are the same, 17. So you just rewrite the numerators. Negative 8 plus 4. Negative 8 plus 4 is going to be negative 4. And 17 is already prime. So I know I can't reduce anything. So negative 4 over 17. Are there any questions so far? All right, because once you, excuse me, once you kind of know what you're looking for, everything is like a downhill slope. All right, so real quick, I kind of want to bring this up because the previous example, this happened, and I want to make sure that everybody knows that these are all the same thing. In fact, here, I'm going to write it like this. Be more specific here. Here we go. So sometimes you will see us, when we write a fraction and there's a negative sign, if the negative is on the top or the bottom or the middle, it doesn't care. We don't care. They're all the same exact thing. So, for example, with the problem I have here, do you see how I wrote the negative 4? Oh, sorry. See how I have this negative 4 and I put like the negative on the 4? I could have wrote the answer like this, with the negative right in the middle. It's all the same thing. And that's what in that big gold box on the next page, it says, in general, the following is true. What they're saying is, it doesn't matter where the negative goes, because no matter what, this entire fraction is still negative. Okay? Now we get into the fun part. Finding least common denominators. All right, so this is setting us up for the next section. Okay, this is setting us up for the next section. And the next section, and I'm going to write this out. You don't have to worry about this, okay? In the next section, I'm going to ask you to add 1/2 plus 1/3. Okay? You cannot do that. You can't do that right now because these two little drawings that I have, they're not the same. The first one is broken up into a group of 2. The second one is broken up into a group of 3. You cannot add these the way they look right now. You can't do it. All right? So what we're going to have to do is we're going to have to learn how to find a least common denominator. All right? And it's really easy to do. There are 3 simple steps. Step 1, write the prime factorization of each denominator. Step 2, for each different prime factor, circle the greatest number of times that factor occurs. And then step 3, the LCD is going to be the product of the circled factors. Let me show you what this is. Here's step 1. Excuse me. Oh. There we go. Much better. I was wondering why when I looked at that it didn't make sense. So step 1, you're writing the prime factorizations of each denominator. So the prime factorization of 25 is 5 times 5. The prime factorization of 30. So if you need to, remember, write out your tree and then break it down. 30 is 2 times 3 times 5. So there's step 1. Step 2, let me write that cleaner. Come on. My handwriting is so bad today. Step 2, for each different prime in step 1, circle the greatest number of times that factor occurs. So, in step 1, I have 2 5s here, but I only have 1 5 there. So I'm going to circle the 2 5s because that's the greatest number of times I see it. The number 2, I only see it once, and I see it right there. The number 3, I only see it once, and I see it right there. Remember, for each different prime factor. So 2 is prime, 3 is prime, and 5 is prime. We're going to circle the greatest number of times we see it. Now, step 3 says your LCD is going to be the product of the circled factors. So step 2, give me 1 second here. Oh, I can't do that because I don't have my mouse. I lost my mouse. I have no idea where it is, so I have to rewrite everything real quick. All right, step 3, finally. My LCD is going to equal 2 times 3 times 5 times 5. And whatever that multiplies out to. So our LCD is going to be 6, because 2 times 3 is 6. And 6 times 25 is 150. So that's what my LCD is here. Okay? So all we're doing is learning how to build an LCD. Are there any questions with how I did that? I just followed the steps. All right, so let's do letter B. So step 1, we're going to write out the prime factorizations. So 40 is going to equal. Now, what I'm going to do underneath is I need some space here because I'm going to write it out. So 40 is going to be 5 times 8. And I've done 8 a lot. So I know 8 is 2 times 2 times 2. So 40 equals 2 times 2 times 2 times 5. Are there any questions there? All right. Now we need to do 108. I definitely need a little bit more space. So 108, if I cut it in half, that'll be 54. Circle the 2 because it's prime. 54 is 9 times 6. They're both composite. So I'll break down the 9 into 3 times 3. And the 6 into 2 times 3. So 108 is going to be 2 times 2 times 3 times 3 times 3. Okay? Any questions so far? All right. So step 1 is done. Step 2, you're going to write out excuse me, you're going to write out all the different primes and circle the greatest number where they occur. So give me 1 second so you can see what I'm doing. I just rewrote it. Now, the number 2, 40 has 3 2s. 108 only has 2 2s. So here's the greatest amount right here. Does that make sense, everyone? Now, the number 3, that's a different prime. The number 40, it doesn't have any 3s. However, the number 108 has 3 of them. So I circle that. And then the last prime is the number 5. I only see 1 in the number 40, so I only circle 1. So step 3, my LCD is going to be the product of all of the ones circled. 2 times 2 times 2 times 3 times 3 times 5. So you can kind of help yourself out a little bit. I know 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. And I'm not even going to kid. I'm just going to go ahead and just type in 8 times 27 times 5. So my LCD is 1080. Now what this means is this. 1080 is the first number that I could take 1080 divided by 40 and get a nice whole number answer. No remainder. And I could take 1080 and divide it by 108 and get the same exact thing. No remainder. That's the first number I can do that with. All right. So we'll do the last one here. And once you, like I said, if you just know your steps, this is very simple. Just take your time. Step 1. We're going to find the prime factorizations of each one of these numbers. All right. So 20 is 2 times 2 times 5. 24, I'm going to have to write that one out, so I'll do it off to the right. 24 is 2 times 12. 12 is 2 times 6, and then 6 is 2 times 3. And then the 45, I can do that one in my head. So 45 is going to be 3 times 3 times 5. So for step 2, I'm just going to rewrite it real quick. Okay? Now, I'm going to go through each different prime and circle the one where I see the most. Oops, that's already wrong. So for the number 2, 24 has 3 2s. So I circle that. The number 45 has 2 3s, so that's the most I see. Now the last prime, number 5, 20 has one of them, 45 has one of them. Doesn't matter which one you pick, because all you need is just one of them. Because remember, it's the max number of that prime. So the LCD for the numbers 7 over 20, 1 over 24, and 13 over 45 is going to be 2 times 2 times 2 times 3 times 3 times 5, which is a very special number. 360. Okay, are there any questions? All right, well, it's 10:58. Class is over at 10:59. So I'm going to leave us with this. The last objective is building equivalent fractions. So if you want to read this over, go for it. But the idea behind this is you're taking a fraction and you're multiplying it by the number 1. It's kind of hard to see. Maybe if you look on your screen. But the key is what we're really trying to do here is we're trying to rewrite a fraction so that we can add it to another fraction. So for now, just know how to find an LCD, know how to multiply and divide fractions, know how to add fractions with a common denominator. Sorry, my voice is going. So if you have any questions, just let me know.